Textbooks open to page 137. Let's take a look at your homework that you did last night. Page 137, the review 1 through 9 is where we're going to start. And this is just a review of some of the most basic algebra, some of the chapter 1 stuff that we talked about, and some stuff from last chapter there in number 9. But most of that, 1 through 8 of it, was just order of operations, signed numbers, combining like terms. A good refresher for us to work some of those more simplistic problems. You also had numbers 12, 14, 16, 18, further up on the page in the practice. We'll go over that second. So we're going to start by looking at the review. Bueno and bueno. All right. Number 1, what did you get when you combined 4 and negative 3, Maddie? Positive 1. 7 minus negative 5, Noah.
12.
Positive 12, add the inverse. Number 3, when you multiply all those things together, Brecken.
I don't know if this is right. I got 960.
Oh my. Maddie?
60.
Should have been positive 60. Let's take a look real quick at this. We've got 2 negatives, first of all, which you know is going to give you a positive, right? So cancel the 2 negatives. And there's a 2, a 4, a 5, and a 3 halves. Now, Brecken, we want to start by canceling the denominator, 2, with one of the numerators, preferably the 2. And then it's just 4 times 5 times 3. 4 times 5, 20 times 3 is 60. For redemption, number 4.
Negative 1/2.
Negative 1/2 is correct. Number 5, what did you get when you removed parentheses, combined like terms? First of all, Noah?
You want me to give you the answer?
Not the final answer. I want the simplification first, and then we'll get the evaluation.
Negative 6, positive 12, positive 8.
Okay, so maybe we misread the instructions. It said to simplify each expression and then evaluate x equals negative 3 and y equals 2. So we should have first removed parentheses by distributing the 4, or the negative 4 rather. We're on number 5. Distribute the negative 4.
Negative 4x, positive 4y.
There we go. And of course, we had a 2x at the beginning. We should then combine like terms to get
2, negative 2x.
negative 2x, positive 4y. So this was the first step. This was simplify. Then evaluate. So that's where we plug in the negative 3 and the positive 2. That gives us a positive 6 and a positive 8, which does give us 14, which I believe was your answer. Right, so but it wanted you to simplify first, then do the evaluation. So on number 6, Maddie, what did you get when you simplified? Okay, simplify means remove parentheses, combine like terms. Let's remove parentheses, Maddie. All right, and then the only combining of like terms is the y's. Positive 2x, positive 8. That's simplify. Now we evaluate negative 3 for x, 2 for y, and what does it give us for our answer?
14 plus negative 6x plus 8.
Not 6x, just 6, right? The 3 is in for the x, and then this is 8 plus 8 gives us 16 for our final answer. So this was the simplify, that was the evaluate. Does that make sense what those instructions mean? So number 7, at your seats, go ahead and simplify, since we didn't quite understand what we were doing there. Also, evaluation is so much easier if you simplify first. Check your simplification. Right here, the inner set of parentheses had a negative in front, looking up this way. So all three signs should have changed. That's step 1. Step 2, go ahead and then distribute the 3 all the way through. Step 4 is to combine the few things you are able to combine. And we should have gotten a 5x negative 18y positive 3. Questions on this? Now we're ready to evaluate very easily. We have a negative 3 for x and a 2 for y. Here when we multiply bracket, we get? Not 15x. The 3 is in place of the x. It is negative 15. When we plug the 2 in for the y, we get? And then, of course, we have a positive 3. We combine it all together to get negative 48. How many had that answer regardless? Okay, it was a challenge, I think, on this one to try to evaluate if you didn't first simplify. Questions on number 7. All right, so I expected this to be a lot easier than it was. Maybe it's a good thing we're doing some review, right, here at this point. And number 8, really easy simplification here, Noah.
Y squared, negative 2x squared, positive 2 y squared.
Combine.
3y squared.
Negative 2x squared. Now here we're plugging in a 2 for the y, we're plugging in a negative 3 for the x. Question, class, do I multiply and then square, or do I square and then multiply? Square and then multiply. Exponents come before multiplication, division, order of operations. So we're going to start by squaring the 2, class, then times 3. We're going to square the negative 3, class, positive 9, times negative 2, negative 18, to get an answer of? Negative 6. Anyone have that answer on number 8? Okay, Maddie, you did. Questions on this, evaluating after you simplify. All right, make sure we, hopefully that was a good refresher for us. Let's take a look at number 9. And we were given this line, 5x negative 4y is equal to 12. And we were given this point, negative 2, 1. So here's our given line. Here's our given point. For part A, we were supposed to find the equation of a line that is parallel to the other line through the given point. Okay, so a lot of abbreviation here because I'm lazy, right? Equation of a line parallel to the line through the point. Whenever we see parallel, Noah, we need to be thinking 2 words.
Same slope.
Same slope. So my line is going to have the same slope as this line does. The problem is, I don't know this line's slope. How? Bless me. Thank you. All right, how might I find the slope of this line, Brecken? Right, get it into y equals mx plus b. Really, I don't even care about the b, I just care about the m part, right? So to get it into y equals mx plus b, what might I do? A couple ways I could go here.
Double swap the negative 4y over the positive 4y, and the 12 over negative 12.
Good, let's pull the double swap here, and then to get the y by itself, of course, just divide everything class by 4. Now here, I'll get a negative 3 when I divide by 4, but I don't really care. All I care is right here. I can see the slope. Class, what's the slope? 5 over 4. So that's the slope of my line, because my line is parallel, right? And if it goes through the point, negative 2, 1, how do I use that information then to find the equation of my line that is parallel? Maddie? Good. Y equals mx plus b, where you plug the 1 in for the y, the 5 fourths for the m, the negative 2 over 1 for the x. Excellent. And then, of course, we need to simplify. There's a little canceling we can do, Maddie, to get... So don't lose the fact of the negative here, right? So we've got a negative, a 5, a 1, a 2, and a 1. So all of this becomes what, Maddie? Halves. Did you say that? Okay, I heard the 5 part. Negative 5 halves plus b. And at this point, there's a couple directions I could go. Noah? When in doubt, if it's an equation and there's fractions, yeah, just get rid of the fraction. Multiply everything by 2 to get what? And then, of course, we can move the negative 5 over as a,
Positive.
to get
7.
7 equals 2b. And then b must equal 3.5, or we'd say 7 halves, unless we were graphing it, right? Then the 3.5 would help. So if that's my m and that's my b, what is my equation, Brecken? Back to you.
Y equals 5 plus x plus 7.5.
And there we go. How many have this answer for part A? Questions on getting part A? All right, let's take a look at part B, because part B wanted the equation of a perpendicular. Still through the point, but a perpendicular. Whenever I see perpendicular, Maddie, I need to think 3 words. Negative reciprocal slope. So we'd already found that our line, the original line rather, had a slope of 5 over 4. So for a perpendicular, the slope is going to be equal to what, class? Thank you, Maddie. Class, what's the slope? Negative 4/5, the negative reciprocal. And of course, we still know it's going through the point negative 2, 1. At your seats, find the equation of the perpendicular. I'm guessing since we botched part A, we probably botched part B as well. So let's go ahead and redo it very quickly. It's like you have such a way with words, Miss Jessie. You couldn't say, we had some struggles. We slightly underachieved. No, we botched it. Wait, thanks. I just call it like I see it, folks. It's like Noah's running his laps on the endurance run. It's like, you could say, Noah, try harder. You can do better. No, Noah, you're slow. Actually, you don't have to run this endurance run, do you? Yeah, because you ran so fast last time. You get out of this one. So while you're sitting there watching everyone else run, I'll just holler at you, you're slow, just for the fun of it. And Gavin be like, you know, this mobile thing got its perks. No, I already emailed your mom, Gavin, and asked her if she could bring you back so you can do an endurance run with us. Okay, I'm kidding. I didn't really do that. Maddie's like, you're a horrible person, Mr. Nasty. Did we get this equation when we reworked it? All right, so for homework, did anyone happen to get that for homework, correct? Okay, you did. So you somehow missed the parallel, but you got the perpendicular? Okay, all right. Well, good. I'm glad you got the perpendicular. You guys missed it in the homework, but you got it now. All right, do we understand what we're to do here? All right, let's look further up on the page then at numbers 12, 14, 16, 18, solving inequalities. And we solve an inequality really the same way we'd solve any equation, except for one key difference, Brecken. What?
I said they're not equal.
No, that's not my question. I said there's in how we solve it. Now, what's the difference between an equation and an inequality? What's the difference in how you solve an equation and an inequality? We solve them the same way, except
You multiply or divide by negative, you flip this on.
good. If you multiply or divide by a negative, you flip the inequality around. Otherwise, you solve them the exact same way. Yes, at their very core, they're obviously vastly different because one's equal, one ain't, right? But and one gets, this is your answer, and one is, these could all be your answers, right? All of these numbers could work. And the other's like, no, it's got to be this one. Anyway, kind of like, you know, Christianity and all the other religions. Well, there might be lots of gods, lots of ways to heaven. And Christianity is like, no, it's this way. And that's why so many people hate Christians, right? They seem closed-minded, but truth is truth, right? Truth is by its nature exclusive. If the truth is that Noah is 5'8", okay, then he isn't 6'5", no matter how much he wants to think he is. He can say he's 6'5", but he's not. He's 5'8", and he can't dunk. If he were 6'5", he would be able to with his jumping ability, but he can't, okay? It's facts, okay? It doesn't matter what you feel like or wish would be the case, right? So it is with Christianity, right? There's one way to heaven through Jesus Christ by accepting his atonement on the cross. It doesn't matter if you wish there were other ways or it just feels like something else should work too. Sorry, truth doesn't care what you wish happened, right? Truth is truth. Anyway, looking at numbers 12, 14, 16, and 18. Number 12. I had some decimals to take care of. What did you get when you finished solving, Maddie? X is less than 3. Number 14 had some fractions we had to get out of there. Noah?
X is greater than -1.
Ooh.
X is greater than 1.
X is greater than +1. We'll take a look at that in a minute. Number 16, back to Noah for redemption.
X is greater than 1.
X is greater than 1 again. Good. And number 18, back to Maddie. Good. X is greater than or equal to 7. Anyone go 4 for 4? All right. Noah, was 14 the only one you missed? All right. And Maddie? Also 14. Let's take a look at 14. We have the negative half x, positive 4/5 is less than 3/10. I assume you multiplied everything by 10. Is that correct?
Yeah. Okay,
so first step was there. Now, when we canceled, did you get a negative 5x? Okay, good. Did you get a positive 8? Okay, and then is less than 3. All right, so we should have moved the 8 over as a negative 8 to get a negative 5x is less than, well, this is one way to do it, is less than negative 5. Divide both sides by negative 5, and then since you're dividing by a negative, this has to flip and become greater than, but negative 5 gives positive 1. That's one way to do it. The other option would have been to say, well, I don't want a negative x. I don't want to have to flip nothing. So I'm going to move this over and pull that double switch thing we talked about before. I'm going to bring the 3 over as a negative 3 to get 5 is less than, and then the negative 5x is moving over as a positive 5x. Divide both sides by 5, and x is greater than 1, or we can say 1 is less than x. Either way we want to look at it. Does that make sense? Okay. I'm guessing something to do with the sign here was the issue. Yes, no, feedback?
The 5, this side, that one.
You didn't get a negative 5. Yeah. Okay, yeah, so careful. So right here, keep the sign of the greater absolute value. Matt?
I divided by positive 5, and so I got 0.
Oh, so you had a negative 5 here, but instead of dividing negative 5x by the negative 5, you just divided by the 5 part. So technically it should have still been negative x here, but then here it would have been not 0 though, when you divide negative by positive, negative, and then 5 divided by 5 would have been 1. So it would have had negative x is less than negative 1 still. So a couple little things there. All right, turn over to page 138. Flip the page. Page 138. And I want you to do all of the blue problems on page 138. Page 138, I want you to do all the blue problems. However, on numbers 1, 4, and 7, I want you to graph the solutions. You'll notice the instructions say to graph the solutions. We're not going to do all of them, but we are going to graph the first 3. So doing page 138, the blue, 1, 4, and 7, go ahead and graph. The rest of them, for sake of time, we won't actually graph them. Working quickly, but accurately. Good overall thorough review of inequalities. Once you're finished, check your answers against the board. I have double checked to make sure they're all right this time, and they are. Gavin, once you're finished with yours, you can check your answers against the board. Of course, if everything's good, you can fast forward the video until you see me erasing everything off of the board. The rest of you who are in here know you are not allowed to fast forward me. Sit there and suffer. However, once you're finished, do please check your answers and see how you did. It's like Noah's finished and is checking. Obviously, too, Gavin, if you need a little bit more time and I'm ready to go over answers, you can always pause me. They can't do that either. Rough life, isn't it, Brecken? Those in here have just about another minute to work, and then we'll go over these together. So get as far as you can in that next minute. Noah, there are 10 problems on the board. How did you do out of 10?
I got 6 right.
Got 6 right, so 4 wrong. Okay. Do you understand the 4 that you missed? Do you see, based on my work, what you should have done?
Yes.
All right, so no questions at all. No, I don't see how you did that. All right. All right, Maddie and Brecken, at this time, if you would go and pause where you're at, forget the ones you didn't get to. How did you do on the ones you did get to? So check your answers on the ones you did finish. All right, Maddie, finished checking? How'd you do? Only missed 2 of the ones you did. All right, on those 2, seeing if you can figure out what you did wrong or what I did differently. All right, Brecken, of the ones you did, how many incorrect?
2.
2, okay.
1.
Number 1 or just 1?
Just 12 is the only one I missed.
All right, number 12. Yeah, number 12 is it comes out to a really strange answer, which is a bit of a bummer, right? But again, combining, not canceling, otherwise you get nothing, right? There's no way to solve if you cancel those. And then I just had to multiply everything through by 7. You could have multiplied by 7 up at the top, but it's one less multiplication if I combine first. Again, a lot of negatives. And it might have been tempting here, I'll be honest with you, class, to say, let me either move everything, switch sides, or just knock out the negatives, right? Make this an 80, make this a less than, make this an 84x, make this a positive 56. Okay, now I'm putting a negative 56, getting 24 less than 84x. And again, when I divide, by the 84, not by 24, reducing by 12. So this is what we start with, but I can divide a 12 out of both of these, and that's where we get the 2/7. So 24, 84 isn't wrong, just minus the point for not reducing if we left it there. All right, any other questions on any of these? Any other questions on any of these? Obviously, again, these are all written with the x on the left-hand side. These were written with the x on the right-hand side. What would this look like if I wanted the x here? What would I have to write, Brecken? Right, x is greater than 2/7. Here we could have said x is greater than or equal to 5. And that would have been the same answer, right? It's just flipped around, just make sure the mouth is open to the same thing. Any questions at all on these? Tell you what, I think I'm going to push your quiz that we were supposed to take today. We're going to push that back to Monday. Okay, so we've got a lot more practice like this in the homework. Okay, we had 4 wrong, 2 wrong, 2 wrong. Let's practice some more in the homework. We'll take that quiz Monday. We'll go ahead and move forward then. Page 141 in your textbooks. Page 141 in your textbooks. And we've done this before, right? With a lesson or two ago, I believe it was, when we translated word statements into inequalities. On page 141, numbers 1 through 4 are like that. So at your seats, if you would, translate numbers 1 through 4 into inequalities. The difference is, when we were doing it before, that's as far as we could go. Now we can solve. So translate into an inequality and solve. Page 141, numbers 1 through 4. And of course, Gavin will remind you here if you had any questions at all on what we were working. You know, there was one just like, I wish you would have gone over this one. By all means, have Mom email me, and I'll go over that with you, video chat later. Okay, so that's an open invitation at any time for anything. You don't have the benefit of asking questions in class, so the only way you can do that is have Mom email me, set up video chat, and we'll take care of that then. But I definitely don't want you to feel that you can't ask questions. You can, you just can't do it while I'm recording. finish, again, check your answers. Checking first to make sure you wrote the inequality correctly, then checking to see that you got the correct answer from it. Noah, good to go? Maddie, good to go? Ann Brecken, good to go. Excellent. Look back, if you would, at page 139 now. Look back at page 139 now. We're going to begin working word problems that involve inequalities. And the way you're going to recognize inequalities, they're going to use language like less than, is greater than, is at most, is no more than, is at least, things like that. Look at example 4.5a on page 139. Read that example problem for us, if you would, Brecken.
The Frey family wishes to pay at most $151,000 for a lot and house. What is the most they can pay to build a house if the lot costs $32,000?
Is at most, correct? That's the phrase that was used. So I know I'm not going to use an equal sign in this particular word problem. They want to pay $151,000 for lot and house. Lot being ground you build house on, house being what you live in that sits on ground. Okay? And they already have a lot in mind that they want to buy. This lot, it says cost class $32,000. We know the cost of the lot. That is not an unknown. What we do not know is how much is the house going to cost, right? Because they only have a certain amount they can budget for it, correct? So, since we don't know how much the house is going to cost, we can call it class X. But they're not just buying the house. They're going to pay to have the house built and or plus, and meaning plus, we're going to have a lot that costs $32,000. And to say equals $151,000 would be a lie. Because let's face it, if they could spend less than that, they'd be happy, right? At most, $151,000. So not equals $151,000 class, but is less than or equal to $151,000. Does that make sense? Here's how much the house costs. Well, I don't really know it, so I'm calling it X, plus the lot, and it needs to be less than or equal to $151K. Hey, if we can get out of here for $125K and have a nice house, let's do it. A nice house that's big enough? Yeah, I can find a builder who's going to build it for me cheaper. Absolutely, I'm going that route, right? So, do we understand that's how we would set this up? And then, of course, you see the example there. Of course, they subtract the $32,000 away, and they get $119,000. So that's the most money that they can spend on a house. Less than that, absolutely, but that is their top figure that they can agree for the builder. Questions on this? Do we see that it's just like ordinary word problems we've done before, but with a less than symbol or greater than symbol? Look at the next one, example 4.5b. And Noah, go ahead and read this one for us.
The Chess Club is having a spaghetti dinner to raise funds at $4 per dinner. How many dinners must they sell to make at least $350?
I'm not sure if they're going to use the money to buy more chess sets or if they're going to use it for travel expenses, to go travel to some big chess tournament. I don't know. Everything can be virtual these days. But anyway, $4 a dinner. The question is, how many dinners do they have to sell? Well, I don't know how many dinners. But class, you realize that's the only thing I don't know, right? So that's all I don't know. I can represent it X, the number of dinners. I do know every dinner is going to sell for $4. How would I show X dinners being sold for $4 a dinner? 4x. We take the number of each, x times the value of each 4 to get the total value. The total value of these spaghetti dinners is 4x. And they need the money from the dinners to be at least $350. Well, what does at least mean, class? Greater than or equal to. More than 350 is great. This needs to be greater than 350 or equal to 350. At least $350. Make sense? And of course, you see in the book there, they divide away the 4, they get 87.5. They have to sell at least 87.5 dinners. Thoughts? Can you sell a half a dinner? Maybe you find a way. Probably not. So if this is their bottom number is 87.5, since they need to make at least that, well, we would have to round up or down. We'd have to round up, because you understand if you round down and say 87, 87 isn't at least 87.5. We have to round up to say 88. dinners. Does that make sense? At least 88. Now, let's suppose that there was some sort of rule that the school had that if this chess club makes over 350, they have to donate proceeds to the principal. I don't think that's such a bad policy. But anyway, and they're like, okay, we hate our but they don't want extra money. Okay, they want at most 350. They do not want to go over that number. By the way, this is how some rich people approach tax season. There's different tax brackets. You make over this number, you're going to pay more in taxes. Like, okay, I need to keep my value at this number or lower. Okay, because I don't want to go into that next tax bracket and be paying that much percentage. Okay, so let's just suppose for some weird reason, and I'm not sure what, they had at most. Well, that would be less than or equal to, right? Well, normally, if you were just asked a junior higher, 87.5, what does that round to? They would say 88. But that would be not less than or equal to. So here the inequality tells me, I don't care what you normally would have done, we have to round down. This could be 87.9, and if x is supposed to be less than or equal to 87.9 dinners, you round down and say 87. That's something new. Does that make sense, though? The symbol tells you how to round, not the old rounding rules you had in the old days. The symbol, only in an inequality problem, but the symbol would tell you how to round if you had to round, right? And since you can't have a 0.9 dinner, rounding down. Make sense? Questions on that? Flip the page. Example 4.5c. Go ahead and read this one for us, Maddie. All right, you probably would remember from last year, past years, talking about commission, right? Commission's what a salesman gets when he sells stuff. So if Noah is a car salesman, he wants to sell a lot of cars, not because he gets all the money from the cars, but he gets a piece of the pie. And on purpose, people that are in sales for things like houses, like a realtor, cars, even furniture sometimes, these salesmen, they don't get a very big paycheck on purpose because the boss wants them to be incentivized to sell. If you can live off your salary, you don't care if you sell anything or not. But if you go hungry on your salary, you're really motivated to sell stuff, right? So that's kind of where Mr. Freeland's at. You cannot live, well, if he's got a wife and kids, you cannot live on a monthly salary of $1,200. You cannot do it. But if he sells enough cars, he can make a whole lot more. In fact, he's kind of figured he probably does have a wife and kids because he somehow needs $3,275 a month. Okay, I don't get that. So, and I can live with me and my 4 kids. So he's probably had more expenses than I do. Let's just put it that way. He needs $3,275. Now, the $1,200 is guaranteed, right? The question is, how many what does he need to sell? How many cars does he need to sell? We don't know. So let's represent that number of cars class as X. And for every single car he sells, he gets how much kickback? 325. So instead of a percentage, it's just 325 for every car. How would I show $325 for every car? 325x, the value of each times the number of each, right? But in addition to that, or plus, he gets $1,200 salary. And all this money, his commission plus his salary, needs to be at least $3,275. How would I say at least, class? Greater than or equal to at least $3,275. If he makes more than that, is he happy? Oh yeah. More than that's good. Less than that would not be. So you can make more than $3,275 or equal to, right? But greater than or equal to $3,275. To solve, you can see the work there. They subtract the 1,200. They divide away the 325. And notice they get that the number needs to be greater than or equal to 6.4. You cannot sell a 0.4 car. Now, your parents may have bought a used car one time. They're like, I got a 0.4 car. Okay, but no, you cannot sell a 0.4 car, right? It's got to be entire, even if certain things are messed up about it. It's still an entire car. Otherwise, it wouldn't be sellable. Normally, if you were in junior high, we'd say 6.4 class would round to 6. But it has to be greater than 6.4. So I have to round up to 7 cars minimum. So every month he's got to sell at least 7 cars or he's not going to be able to pay his bills. So again, you get down to that last week of the month, you got one motivated salesman. So strategy tip, folks, let's think for a minute. If the end of the month, salesmen haven't been hitting their goal, they're really motivated to sell, right? So if you're like, no, I don't want to pay $23,000 for that car. I'll give you $19,000 for it. Beginning of the month, you might be like, I'm sorry, I can't do that. End of the month, he's like, I've got to sell this car. Please, manager, would you please let me go down to $19,000? I really need the sale. Manager crunches numbers to tell you what. See if they'll go down to 20. Meet him in the middle. Like 20. You just save yourself $3,000 if you take that deal. See? So buy at the end of the month, not at the beginning of the month. Smart. Anyway, anyway, and never pay full price for a car, right? Always offer them less than what they're asking. See if they'll take it. You know, they might. If they don't, you walk away. And they might come running after you and begging you to come back. Or you might go get a better deal somewhere else. Always offer less. Anyway, it doesn't work that way on groceries. Let's see, this box of cereal. Y'all say $3.99 for this box of cereal. I give you $2 for it. Doesn't work that way at the grocery store, but it does work that way in the car lot. It does work that way at furniture stores. And guys, it works that way at jewelry stores. Yeah, so when it comes time, you found that girl. And you're going to put this diamond ring on her finger, guys. It may say one thing on that price tag. But you walk in and you say, this is all the money I got. Can I have that ring? That's the ring I want. This is how much money I got. Will you give it to me? You might be amazed. Okay, I went in and I didn't like any of the rings I saw for a while. I saw this one. It was like $500 more than I had. I cashed out my entire savings account, which wasn't that much, okay? It wasn't a whole lot, but I cashed out my entire savings account. I had it in cash in my hand. Well, in my pocket, but I had it on my person. I was like, I really like that ring, but this is all the money I've got. It's my entire savings. I don't have anything else. And they're like, well, let's see what we can do. Let's see what we can do. They made some phone calls. Guess what? You'll never believe this. They gave it to me for $2 less than what I had in my bank account. You know, I had $2 change back and included a lifetime warranty and cleanings and blah, blah, blah. Saved over $500 on my wife's engagement ring because I had cash and I offered less. So strategy tip, right? Yeah. So don't settle for what you can afford. See if you can get something even better than what you can afford because she's worth it. Especially if they give it to you for no extra money. All right. Anyway, side note. Let's go down to example 4.5D. And Noah.
Sharon has $115 to spend on a dress and shoes. The cost of the shoes will be at least 1/3 of the cost of the dress. How much can she spend on the dress?
All right, so there's two things we don't know here, right? We don't know the dress, we don't know the shoes. And you guys are like, it costs $115 for a dress and shoes? It can. And yeah, anyway, it's expensive having a woman, I tell you. Anyway. But if you love her enough, she's totally worth it. Anyway, so we've got the dress. We don't know how much that costs, so we could call it X. And we don't know the shoes either. They cost 1/3 as much. 1/3 X. And together, they're going to cost Sharon, well, you can't go over 115, kind of like me walking in for the engagement ring. This is all the money I got. So if you want to sale, you got to give it to me this price because I literally can't pay more. Okay? Sharon's only got how much money, class? 115. So she could spend all 115, or if she gets a better deal, maybe she could buy you like hamburger on the way home. Anyway, so all she's got is $115. So this money that she's spending on dress and shoes has got to be less than or equal to the 115. Now again, here we've got fraction, multiply everything by 3, right? And what is that, 345? And we get 4x is less than 345. When we divide by 4, that's not going to divide evenly, is it? It's going to come to, what is that, 86.25. That's an actual money amount. We don't have to round this time. She can get a dress that's $86.25. No reason to round. Cars, you can't have a 0.4 car. You can't have a what's a 0.5 ridge? You can't have a 0.5 spaghetti meal. Okay? You can have 0.25, that's just 25 cents. So here we don't need to round. She can spend up to $86.25 on the dress, assuming the shoes really do cost a third the cost of the dress. Questions on that? Questions on that? All right, your homework for this evening is to do pages 138. We're going to look at more word problems after your quiz on Monday. So quiz coming up Monday in our next lesson. We're going to go over the homework, which is page 138. Numbers, there's 12 of them. 5, 6, 8, 9, 14, 15, 16, 26, 27, 35, 36, and 39. 12 strategically picked problems for you to practice prior to the quiz. All right, 5, 6, 8, 9, 14, 15, 16, 26, 27, 35, 36, 39. Those 12 problems for homework. We're going to go over the homework. You're going to take the quiz. Then we're going to look at more word problems after that. Have a wonderful rest of your day, and you are dismissed.